Alright, guys, we are going to deal with the story of phenylalanine. So, first of all, for a story, we need a storyline. So, our storyline starts from phenylalanine. Phenylalanine, it's then converted to tyrosine. Tyrosine then converted to dopa, more specifically L-dopa. Then we have dopamine. Then we have norepinephrine. Then we have epinephrine. So this is our storyline. From phenylalanine, we have tyrosine, L-dopa, dopamine, norepinephrine, and epinephrine. By heart this line. You need to keep it in your head. Okay. So from phenylalanine to tyrosine, we need a supporting actor. Who is that guy? This phenylalanine hydroxylase, which hydroxylase phenylalanine to give tyrosine. Okay. Phenylalanine hydroxylase with the help of pH4 tetrahydropterin. So I'm correlating some clinical issues with this storyline also. We have a clinical issue over here. What is that badass issue? If we are deficient with an phenylalanine hydroxylase, this particular enzyme, we can get an autosomal recessive disease called phenylketonuria. What it is? Phenylketonuria or PKU. Okay, we have enzyme in this particular phenylalanine hydroxylase enzyme, we get PKU or phenylketonuria. Means that phenyl ketones are accumulated in urine. That's phenylketonuria. Okay, pretty simple. From the phenylalanine hydroxylase, we can get tyrosine. So from the tyrosine, while we reach tyrosine, the tyrosine can actually go to two pathway. Total three pathway. The main storyline, including the main storyline, we have three pathway. The first pathway towards the right side, we have homogendecyte or homogendecytic acid. Homogendecyte. We have homogendecyte. From the homogendecyte, we are going to get malaloacetic acid, malaloacetoacetic acid, acetoacetic acid. How we can get a homogendecyte, malaloacetic acid from homogendecyte? Pretty easier guy, homogendecyte oxidase. Just oxidation of homogendecyte acid, we can get oxidase. Actually, it is dioxidase. Sorry, dioxidase. Okay, or either oxidase. Anyway, we are getting the oxidase. We can get malaloacetic acid. A pretty good guy also here. Like phenylketonuria, we have a deficiency, autosomal recessive deficiency of homogendecytic oxidase. We can get L-captonuria. Okay, L-captonuria. Pretty badass. Okay. From the the other fate of malaloacetic acid from the malaloacetic acid, this then going to give our fumarate. Sorry, it's not fumarate, it's fumarate. I will misunderstand that thing. It's fumarate. From the fumarate, this fumarate is going to finally end up with component of TCA cycle. Okay, getting some kind of energy from phenylalanine. Why? How? From the tyrosines, just take a right turn. Through the right turn, we can get homogendecytic acid. From the homogendecytic acid, we can get myeloperoxidase. From the myeloperoxidase, we can get fumarate. Fumarate can end up with TCA cycle, giving up pretty kind of some ATP. Okay, that's the right side story. So what is the left side story then? From the left side story, we have thyroxine. What is thyroxine? This is a thyroid hormone. Okay, so thyroid hormones are made up of tyrosine. Okay, so it makes many sense, some kind of sense over you. So This is the two sideways. So what is our main storyline? Main storyline is phenylalanine tyrosine to L-DOPA, more specifically L-DOPA. So as I mentioned over here, we have BH4 over here, the same guy to help this facilitation of this enzyme activity BH4. Then what is the enzyme here? It's tyrosine hydroxylase. Okay, tyrosine hydroxylase. Sorry, hydroxylase. Okay, pretty good, pretty easy. Okay, we have same BH4 over here, same BH4. We have phenyl hydroxylase. We have tyrosine hydroxylase. Then L-DOPA. Then from L-DOPA, we have what guy? From L-DOPA, we have dopamine. How we are getting the dopamine? With the help of B6. B6. Vitamin B6 we need. And then pretty badass guy. It's a cofactor for DOPA decarboxylase. DOPA decarboxylase. Any time you hearing about the decarboxylase word, this word decarboxylase, just think of B6. It's easy to crack that thing. Okay, B6. Okay, decarboxylase. So, and one more side note here. From the DOPA, there is also a sideway path. The DOPA can take a left to give us melanin. Okay, I need this small long line, then only you can put one enzyme here. Okay, melanin. Okay, melanin. We can get what from melanin? What? Pigmentation of the skin. Okay, pretty easy, guy. Okay, we can get the pigmentation of our skin. How we are transferring the L-DOPA to melanin? It's a tyrosinase enzyme. Tyrosinase enzyme. Tyrosinase. Okay. If we are deficient in this tyrosinase enzyme, anything happens to this tyrosinase enzyme, then what we are getting? Decrease in albinism. Say decrease in melanin. Sorry, I already mentioned that thing. Okay, albinism. Albinism. This is also an autosomal recessive trait. Okay, albinism. Okay, from dopamine we have norepinephrine. Okay, from dopamine we have norepinephrine. How we are getting the norepinephrine? Norepinephrine we are getting with the help of dopamine. What do we have? We have dopamine. Okay, sorry, I don't listen. I need listen. Okay, dopamine beta hydroxylase. Dopamine beta hydroxylase. Okay, dopamine beta hydroxylase. And we need one guy to hydroxylase this dopamine to norepinephrine. That guy is called our ascorbic acid or else vitamin C. Okay, vitamin C. Okay, that's good actually. Okay, from the dopamine. Okay, now we reach up to norepinephrine, but there is also a side way. Like from here, we have a lot of sideways actually. From the dopamine, we have some kind of way. Some of the dopamine can go to and make our. Okay, I'm somewhere down here because I need some more space over here. Okay, we have our homo vanillic acid. Homo vanillic. Okay, you can get this whole image. I will put this whole image of this in description. I will upload in my website. Okay, vitamin C, dopamine beta hydroxylase. We can get homovenilic acid. Some of the the dopamine C with the help of what enzymes? COMT means catechol. With the help of COMT, catechol O methyl transferase and monoamine. Both. We need both actually. We need both. It's a long process. I'm not mentioning all these things. Just understand this. Monoamine oxidase and with the help of and same the monoamine reaches homoaminic acid. That is the fate of dopamine. Okay. So we have norepinephrine over here. How this norepinephrine is converted to epinephrine. We have some kind of guy over here. We can term this enzyme as a guy. What guy is that? Say Sam. Here his name is Sam. Sam. Okay. This adenyl methionine. It's a kind of methionine component. Okay. Sam with the help of phenylalanine and methyl transferase. Okay. Phenyl ethanolamine N-methyl transferase. Okay, N-methyl transferase. Okay, SAM from the phenylalanine N-methyl N-transferase. But there is also some kind of side way over here. Okay, this norepinephrine. Some of the norepinephrine is going like SAM with the help of SAM and phenylethylamine and methyl transferase, and some of the to epinephrine, and some of the norepinephrine is converted to one guy. This guy is called normetanephrine. Normetanephrine. Okay, normetanephrine. With the help of COMT, catecholamine methyl, the same guy over here, the same guy, COMT, catecholamine, catechol O methyl transferase, catechol O methyl transferase, which is a catecholamine metabolism, catecholamine. Okay, pretty sure, pretty good. Okay, pretty easy to understand everything. So now we reach till epinephrine, right? With the help of SAM and phenylethanolamine and methyl transferase, we reach epinephrine. From epinephrine, so what is norepinephrine and epinephrine? These two guys are our neurotransmitters. Our parasympathetic, sorry, sympathetic activity is modulated by norepinephrine and epinephrine. Okay, it's a part of our flight and fight system of action. This epinephrine and norepinephrine. From the epinephrine, we are again going down. So this is the actual storyline. So this is the tail end. Actually, this is the tail end of this storyline. Actual storyline is phenylephrine, tyrosine, L-dopa, dopamine, norepinephrine, and epinephrine. From this is the tail end. Tail end is going forward. We are going to conclude our storyline movie. So from epinephrine we have metanephrine. Here we have normetanephrine, but here we have normetanephrine, but here it's metanephrine. Okay, metanephrine with the help of, okay, then two of the same guys is coming to converging and end, like, okay, here we have one guy. It's called COMT, again COMT, catecholamine O methyl transferase. See, catechol O methyl, it's not catecholamine, it's catechol O methyl transferase. Okay, then from metanephrine we have monoamine oxidase, MAO, monoamine oxidase. I'm going to end our movie. Vanillin, vanillyl mandelic acid. Okay. So this is our whole story of phenylalanine. We have the story of phenylalanine. We have phenylalanine, which is converted to tyrosine. The main storyline is like this: L-dopa, dopamine, norepinephrine, norepinephrine, and norepinephrine, from metanephrine, and finally valminic acid and a homomanilic acid. This is the end product. Okay, that's our story over here. So, and again, to mention some kind of clinical stuffs here, if we are deficient in phenylalanine hydroxylase enzyme, we get phenylketonuria, means phenylalanine ketones on urine, phenylketonuria. Okay, if we are deficient in homogeneous oxidase, it's giving the tyrosine to homogeneity, we get alkaptonuria. From the L-dopa, it's converted to melanin. So with the help of tyrosine, over here, the tyrosine, we get albinism. Okay, that's all.